Okay, good morning. So, our topic is all about the T test. As quoted by Christopher Monkton, you can prove a hypothesis, you can only improve or disprove it. So, every day we find ourselves testing new ideas, finding the fastest route to the office, the quickest way to finish our work, or simply finding a better way to do something we love. The critical question then is whether our idea is significantly better than what we tried previously. These ideas that we come up with on such a regular basis, that's essentially what a hypothesis is. And testing these ideas to figure out which one works and which one is best left behind is called hypothesis testing. Hypothesis testing is one of the most fascinating things as data scientists do. Now, one of the most popular ways to test a hypothesis is a concept called the t-test. There are different types of t-tests that will be discussed later. Okay, so what is a t-test? A t-test is a type of inferential statistics used to determine if there is a significant difference between the means of two groups which may be related in certain features. It is mostly used when the datasets, like the dataset recorded as the outcome from flipping a coin 100 times, would follow a normal distribution and may have unknown variances. A t-test is used as a hypothesis testing tool which allows testing of an assumption applicable to a population. The t-test is one of the many tests used for the purpose of hypothesis testing in statistics, and calculating a t-test requires three key data values. They include the difference between the mean values from each data set called the mean difference, the standard deviation of each group, and the number of data values of each group. Now, a t-test looks at the t-statistic, the t-distribution values, and the degrees of freedom to determine the statistical significance. To conduct a test with three or more means one must use a analysis of variance. Okay. When should we perform a t-test? Let's first understand where a t-test can be used before we dive into its different types and their implementations. So, I strongly believe that the best way to learn a concept is by visualizing it through an example. So, let's take a simple example to see where a t-test comes in handy. Consider a telecom company that has two service centers in the city. The company wants to find whether the average time required to service a customer is the same in both stores. Now, the company measures the average time taken by 50 random customers in each store. Store A takes 22 minutes, while Store B averages 25 minutes. Can we say that Store A is more efficient than Store B in terms of customer service? It does seem that way, doesn't it? However, we have only looked at 50 random customers out of many people who visit the stores. Simply looking at the average sample time might not be representative of all the customers who visit both the stores. So this is where the t-test comes into play. It helps us understand if the difference between two sample means is actually real or simply due to chance. Okay, assumptions for performing a t-test. Now, there are certain assumptions we need to heed before performing a t-test. First, the data should follow a continuous or ordinal scale. Second, the observations in the data should be randomly selected. Third, the data should resemble a bell-shaped curve when we plot it. Example, it should be normally distributed. Fourth, large sample size should be taken from the data to approach a normal distribution. And lastly, variances among the groups should be equal. Okay, so there are three types of t-tests we can perform based on the data at hand. First, we have the one sample t-test, second, independent two sample t-test, and third, paired sample t-test. One sample t-test in we compare the average or mean of one group against the set average or mean. This set average can be any theoretical value or it can be the population mean. Okay, so consider the following example. A research scholar wants to determine if the average eating time of a burger differs from a set value. So let's say this value is 10 minutes. How do you think the research scholar can go about determining this? Okay, so we have steps. He or she can broadly follow the following steps. First, select a group of people. Second, record the individual eating time of a standard size burger. Third, calculate the average eating time for the group. And finally, compare that average value with the set value of 10. Now, in a nutshell is how we can perform a one sample test. So the formula to calculate this is T equals to M minus mu over S divided by the square root of N, where T is equal to T statistic, M is equal to mean of the group, and mu is the theoretical value or population mean. S is the standard deviation of the group, and N is equal to the group size or sample size. Now, as mentioned earlier in the assumptions that large sample size should be taken for the data to approach a normal distribution. Now, although t-test is essential for small samples as their distributions are non-normal. Okay, once we have calculated the t statistic value, the next task is to compare it with the critical value of the t-test. We can find this in the below t-test table against the degree of freedom, n-1, and the level of significance. Now, this method helps us check whether the difference between the means is statistically significant or not. Next, independent two-sample t-test. The two-sample t-test is used to compare the means of two different samples. Okay, so let's say we want to compare the average height of the male employees to the average height of the females. Of course, the number of males and females should be equal for this comparison. This is where a two sample t test used. So the formula to calculate the t statistic for a two sample t test is t is equal to ma minus mb over the square root of S2 over Na plus S2 over Nn, where Ma and Mb are the means of two different samples, and Na and Nb are the sample sizes, and S2 is an estimator of the common variance of the two samples, such as S squared is equal to summation of x minus ma squared plus summation of x minus mb squared over na plus nb minus 2. Here, the degree of freedom is na and nb minus 2. So we will follow the same logic we saw in a one sample t-test to check if the average of one group is significantly different from another group. That's um that's right. We will compare the calculated t statistics with the t critical value. Okay. The next type of t-test is the paired sample t-test, which is quite intriguing. Here, we measure one group at two different times. We compare separate means for a group at two different times or under two different conditions. For instance, a certain manager realized that the productivity level of his employees was trending significantly downwards. This manager decided to conduct a training program for all his employees with the aim of increasing their productivity levels. How will the manager measure if the productivity levels increased? It's simple. Just compare the productivity level of the employees before versus after the training program. Here, we are comparing the same sample size, the employees, at two different times before and after the training. This is an example of a paired t-test. The formula to calculate the t statistic for a paired t-test is t is equal to m over s divided by square root of n, where t is equal to t statistic, m is the mean of the group, mu is the theoretical value or population mean, and s is the standard deviation of the group, and of course n is the group size or sample size. Now we can take the degree of freedom in this test as n is n minus 1, since only one group is involved. Okay. Calculating the test requires three key data values. They include the difference between the mean values from each data set, called the mean difference, the standard deviation of each group, and the number of data values of each group. Now, the outcome of the t test produces the t-value. This calculated t-value is then compared against a value obtained from a critical value table called the t-distribution table. This comparison helps to determine the effect of chance alone on the difference and whether the difference is outside the chance range. The t-test questions whether the difference between the groups represents a true difference in the study or if it is possible a meaningless random difference. Okay. The t-distribution table is available in one tail and two tails formats. The former is used to used for assessing cases which have a fixed value or range with a clear direction, positive or negative. For for instance, what is the probability of output value remaining below -3 or getting more than 7 when rolling a pair of dice? The latter is used for range-bound analysis, such as asking if the coordinates fall between -2 and +2. So the calculations can be performed with the standard software programs that support the necessary statistical functions like those found in MS Excel. T-values and degrees of freedom. The t-test produces two values as its output, t-value and the degrees of freedom. The t-value is a ratio of the difference between the mean of the two sample sets and the variation that exists within the sample sets, while the numerator value is straightforward to calculate. The denominator can be can become a bit complicated depending upon the type of data values involved. The denominator of the ratio is a measurement of the dispersion or variability. Higher values of the t value, also called t-score, indicate that a large difference exists between the two sample sets. The smaller the value, the more similarity exists between two sample sets. So we have a large t-score indicates that the groups are different, and a small t-score indicates that the groups are similar. Degrees of freedom refers to the values in a study that has the freedom to vary and are essential for assessing the importance and the validity of the null hypothesis. Computation of these values usually depends upon the number of data records available in the sample set. Okay. Correlated or paired t-test. The correlated t-test is performed when the samples typically consist of matched pairs of similar units or when there are cases of repeated measures. For example, there may be instances of the same patients being tested repeatedly before and after receiving a particular treatment. In such case, each patient is being used as a control sample against themselves. This method also applies to cases where the samples are related in some manner or have matching characteristics, like a comparative analysis involving children, parents, or siblings. Correlated or paired t-tests are of a dependent type. Of these involve cases where the two sets of samples are related. So the formula for computing the t-value and degrees of freedom for a paired t-test is t is equal to mean 1 minus mean 2 over s differences over square root of n, where mean 1 and mean 2 is the average values of each of the sample sets, s diff the standard deviation of the differences of the paired data values, n is equal the sample size, n minus 1 the degrees of freedom. So the remaining two types belong to the independent t-test. The samples of these types are selected independent of each other, that is, the datasets in the two groups don't refer to the same values. They include cases like a group of 100 patients being split into two sets of 50 patients each. One of the groups become the control group and is given a placebo, while the other group receives the prescribed treatment. This constitutes two independent sample groups which are unpaired with each other. We also have the equal variance or pooled t-test. It is used when the number of samples in each group is the same or the variance of the two datasets is similar. The following formula is used for calculating t-value and degrees of freedom for equal variance t-test. So t-value is equal to mean 1 minus mean 2 over n1 minus 1 times variance 1 squared plus n2 minus 1 times variance 2 squared over n1 plus n2 minus 2 times square root of 1 over n1 plus 1 over n2, where mean 1 and mean 2 is the average values of each of the sample sets. var1 and var2 is the variance of each of the sample sets, and n1 and n2 is the number of records in each sample set. And degrees of freedom is equal to n1 plus n2 minus 2, where n1 and n2 is the number of records in each sample set. For the unequal variance t-test, it is used when the number of samples in each group is different. The variance of the two datasets is also different. This test is also called the Welch t-test. The following formula is used for calculating t-value and degrees of freedom for an unequal variance t-test. So we have t-value is equal to mean 1 minus mean 2 over variance squared over n1 plus variance 2 squared over n2, where mean 1 and mean 2 is the average values of each of the sample sets. Variance 1 and variance 2 is the variance of each of the sample sets, and n1 and n2 is the number of records in each sample set. And the degrees of freedom, we have var1 squared over n1 plus var2 squared over n2 squared over var1 squared over n1 squared over n1 minus 1 plus var2 squared over n2 squared over n2 minus 1, where var1 and var2 is the variance of each of the sample sets, and n1 and n2 is the number of records of each sample set. Okay, determining the correct t-test to use. The following flowchart can be used to determine which t-test should be used based on the characteristics of the sample sets. The key items to be considered include whether the sample records are similar, the number of data records in each sample set, and the variance of each sample set.